Welcome to Next Gen Manufacturing Nexus. Today, we're going to take you inside the factory of the future. I'm talking about a place where the most complex machines you can imagine are built to absolute perfection, all in the digital world, way before anyone even thinks about cutting a single piece of metal. Okay, so take a look at this. This is the final assembly plant for the Boeing 777. And honestly, it's not just a factory, right? It's more like a cathedral of engineering. But believe it or not, inside this incredible marvel lies a puzzle on an absolutely monumental scale. And here's the challenge, the real question. How in the world do you make millions of different parts, coming from all over the globe, fit together perfectly, I mean absolutely perfectly, on the very first try? Because in aerospace, there's just no room for almost. A tiny error, a millimeter off, and the consequences can be, well, you can imagine. So, to really get our heads around the solution, we first need to appreciate just how huge this problem is. We're talking about a puzzle with, quite literally, millions and millions of pieces. Just think about this for a second. A single Boeing 777 has more than 2.5 million fasteners. That's every single rivet, every bolt, every screw, and each one has to be placed with absolute, uncompromising precision. It's just mind-boggling. You see, the old way of doing things, the traditional manufacturing playbook, it just can't handle this kind of complexity. I mean, in the past, you'd build these giant physical prototypes, make endless adjustments, and basically rely on a whole lot of trial and error. For something as complex as a modern jet, that whole process is, well, it's way too slow, it's crazy expensive, and honestly, it's just not accurate enough. Not even close. So the solution had to be something completely different, a total shift in thinking. And it started with a really powerful question. What if you could build the entire thing flawlessly in a digital world before you even start building it for real? And that brilliant idea has a name, digital pre-assembly, or DPA. It's exactly what it sounds like. You model every single part in 3D, and then you run the entire assembly process on a computer. It's like building with digital Legos. This lets engineers find all the little problems, parts that don't quite fit, misalignments, in the virtual world. And you know what? A fix there is just a few mouse clicks, not a multi-million-dollar mistake on the factory floor. Boeing really went all in on this idea for the 777. They called their strategy 100% digital product definition, and that meant everything, from the tiniest wire to the biggest piece of fuselage, was designed and tested digitally first. The results? It was an absolute game changer. The 777 was the first jetliner ever built without a full-scale physical mock-up. Just think about that. Okay, so a perfect digital model sounds great, right? But here's the catch, and it's a big one. The real world is messy. It's not perfect. Every single physical part that comes off a production line has tiny, almost invisible variations. And let's be honest, a digital twin is pretty useless if it doesn't match the real part, warts and all. So how do you capture that messy reality? Well, the old way, low-density metrology, was basically just taking a few measurement points and guessing the rest of the shape. It was fast, sure, but you'd miss all the critical little errors. The big leap forward is high-density scanning. We're talking about capturing thousands of points. You're not guessing anymore. You're knowing the true imperfect shape of the actual part. And these modern machines, coordinate measuring machines, or CMMs, are ridiculously fast. I mean, one of the papers we looked at mentioned a high-speed CMM capturing an incredible 831 measurement points in just 11 seconds. That's not a trickle of data. It's a fire hose of high-fidelity information telling you exactly what that part's surface looks like. And this quote from Rich Knabel at Carl Zeiss really hits the nail on the head. If you don't know true form, you can't know the functional size and location. Let me translate that for you. If you're just guessing at the shape, you're also just gambling on whether it's actually going to fit and work. Knowing those tiny imperfections isn't just nice to have. It's the only way you can guarantee the part will do its job. All right, so now we've got this absolute torrent of super accurate data. What's next? Well, this is where it gets really cool. We add a layer of intelligence. We're about to go from just measuring things to actually predicting and optimizing them with AI. So let's zoom in on a really specific but super critical problem. A research paper we looked at dug into getting the perfect interference fit for thousands of slug rivets in an airplane. Basically, you need that rivet to be just right, not too loose because that's a safety issue, and not too tight because that can cause tiny stress fractures. Now imagine trying to get that perfect thousands and thousands of times over. It's a huge challenge. So how'd they solve it? With this amazing AI optimization pipeline. Here's how it works. First, they built a physics model to simulate all the complex forces involved. Then they took all that simulation data and fed it to a deep neural network, basically training an AI until it became an expert at predicting the outcome. And finally, they let a special algorithm use that super smart AI to search through millions of possibilities to find the absolute perfect settings. The result? It finds the optimal answer in minutes, a job that would be literally impossible for a human. Okay, so we've gone from the huge scale of an airplane down to the microscopic level of a single rivet. Now let's zoom back out. Because all this digital wizardry is incredible, but what does it mean for the actual people on the factory floor, the ones who have to build this stuff? Well, this is where it all pays off. Instead of having to train someone on a multi-million-dollar piece of equipment, where one mistake could be super dangerous or incredibly expensive, workers can now learn in a totally immersive virtual reality environment. And the research is clear. VR can slash learning time by up to 40%. It's safer, it's faster, and it's just plain more effective. And it's not just a theory, the hard data totally backs this up. Just look at this chart. It's showing how efficient a trainee's movements are over multiple training sessions. See that line? It's a clear, undeniable upward trend. With every single session they do in VR, their movements get more precise, more efficient. You can literally watch them getting better. The learning is totally measurable. And you know what the secret sauce is? Instant feedback. In the VR world, trainees get this real-time dashboard showing them everything: their task completion time, their error rate, all the key stats. This creates this incredibly powerful feedback loop that just skyrockets their learning and helps them adapt way faster than ever before. All right, so let's bring it all together. It's time to recap this incredible journey we've taken from the old physical factory to the new digital-first factory. I mean, the transformation is just profound. We've gone from a world of physical trial and error to one of precise digital simulation. We've moved from just a few data points to high-density scans that tell us the absolute truth. We've shifted from passively measuring things to actively optimizing them with AI. And we've completely changed training from something that was slow and expensive to an experience that's fast, safe, and totally driven by data. And all of this brings us to one final, really big question. This whole digital-first approach, it's not just about building today's products a little bit better. It's about flinging the doors wide open to creating things we can only dream of right now. When you can simulate and perfect every single atom by design, what's stopping us? The limits are no longer physical. They're only set by our imagination. So, what will we build next? Thanks for joining us on Next Gen Manufacturing Nexus.